Hello and welcome to this video on the implementation of an algorithm to find the minimum number of nodes to be selected to light up all the edges of the tree. An edge lights up when at least one node at the end of the edge is selected. In this video, we will be using depth-first search to solve it. First, let's take a look at the function signature. This function takes into parameters n, which represents the number of vertices in the tree, and edges, which is a 2D vector containing the edges of the tree. The first thing we do in the function is to create a vector of vectors called graph for the size of n+1. This will be our adjacency list representation of the tree. We then use a for loop to iterate through the edges and add them to the graph vector by adding the edges endpoints to each other's adjacency list. We then create another vector of vectors called answer with a size of n+1. In this vector, the first dimension represents the node, and the second dimension represents the number of vertices in the subtree rooted at that node. The first element of the second dimension, answer, I0, represents the number of vertices in the subtree rooted at node I if node I is included in the final set of selected vertices, while the second element of the second dimension, answer, I1, represents the number of vertices in the subtree rooted at node I if node I is not included in the final set of selected vertices. Next, we define a helper function called DFS which takes in 4 parameters, the graph, the current vertex k, the parent vertex parent, and the answer vector. In this helper function, we iterate through all the vertices in the current vertex's adjacency list, and if it is not the parent vertex, we recursively call the DFS function on that vertex. As it traverses the graph, it updates the answer vector for each node, based on the number of vertices in the subtrees rooted at its children. Specifically, it updates answer, current, 0, to be the sum of answer, V1, for all children V of current, and answer, current, 1, to be the sum of min, answer, V1, answer, V0, for all children V of current. This is because, when current node is included in the final set of selected vertices, its children must not be included, and when current node is not included, its children can either be included or not included. The final step is to return the minimum of answer, 1, 0, and answer, 1, 1, which are the number of vertices we can select or not select from the root node. And that's it. With this code, we are able to efficiently find the minimum number of nodes to be selected to light up all the edges of the tree using DFS. I hope this tutorial was helpful, and if you have any questions, feel free to ask in the comments. Thank you for watching.